we're looking at a trinomial that looks like it might be difficult to factor because of the 3 as part of the 3x squared and the 36. Looks like we might have to multiply 3 times 36 and find some factors and split the middle term. But then we notice that the 3, the 21, and the 36 are all divisible by 3. So that brings us to an important rule that will make factoring go a lot quicker, and that is always factor out the greatest common factor first, which of course is 3. So we factor out the 3, and now we're looking at a second factor, which is a trinomial, but a lot easier to factor. A little mental arithmetic will tell us that 3 times 4 is 12, and 3 plus 4 is 7. So there it is, and this particular trinomial can be factored relatively quickly. Here's another example. The greatest common factor for all 3 terms is 5. We factor that out. We look at the remaining trinomial. Well, the only way to split up a 25 is 5 times 5 or 1 times 25. But of course, since the 10x is negative, it's going to be negative 5 times negative 5. And there it is. That turns out to be a perfect trinomial square. And we can write it with exponents 5 times the quantity x minus 5 squared. And here's a binomial, but the greatest common factor is 20. So we factor out the 20, and now we're looking at a difference of squares. And there it is. And there is our factored form for 20x squared minus 80. And here's kind of a wild problem, but if we look carefully, we can see there's 3 distinct terms separated by the 2 subtraction symbols. And then we notice that in each term, there's a constant factor that's all divisible by 3. In fact, one of the factors is 3. So the 3 goes into itself, 18 and 6. And then we see that each of these terms contains the binomial x plus 4. So our greatest common factor for all 3 of these terms is 3 times the binomial x plus 4. So we'll factor that out, leaving us with a trinomial 6x squared minus x minus 2. Still not the easiest trinomial to factor, but if we multiply 6 times the negative 2, we get negative 12. And that means we need 2 numbers that multiply to make negative 12 that add up to negative 1. Because where you see the minus x, that's like minus 1x. So we split the middle term because those 2 numbers are negative 4 and 3. So we split the minus x to negative 4x plus 3x. And then we use factoring by grouping to find that the common factor of the first 2 terms is 2x, and the second 2 terms have just a common factor of 1, but we write that because we're going to need that in our final factored expression. We check that our binomials match 3x take away 2, and we factor those out, leaving us with a binomial of 3x take away 2 and another binomial of 2x plus 1 as the factored expression for the trinomial factor 6x squared minus x minus 2. And we notice that we've needed a set of parentheses to show our work, but we don't need it anymore, so we remove it. And there's our factored expression. A constant 3 times 3 different binomials is the factored expression for the original complicated polynomial up at the top of this page. And here's what happens if you forget to factor out the greatest common factor initially. You can still get to the final factored expression, but it just takes longer. So we're going to multiply 4 times 32 and get 128. And since the 36x is negative, we need 2 negative numbers that multiply to make 128 that add up to negative 36. And so we realize that that's the 4 and the 32. So we split the middle term into minus 32x minus 4x. And then we use factoring by grouping to get a common factor of 4x for the first 2 and negative 4 for the last 2. I didn't show as much work as I have in the past, but notice how the plus 32, after we factored out the negative 4, became take away 8. That's important. It's easy to make a sign error on a problem such as this one. And then using factoring by grouping, we notice the binomials are both x minus 8. That's good. We factor it out. But then we realize that the second of our 2 binomial factors, they each have a common factor of 4. So now we factor the 4 out, and it's in an unusual place. So for our final factored expression, we write the 4 in the customary order, and then the x minus 8, and then the x minus 1. But let's compare that if we had just seen that the greatest common factor was 4 right off the bat. There it is. And then we can look pretty quickly with mental arithmetic to finish the job. And what took several steps and perhaps 2 or 3 minutes can probably be done in about 30 seconds if you remember to factor out the greatest common factor first. When factoring a polynomial, always look for the greatest common factor first. Then look for a perfect trinomial square, a difference of squares, or a trinomial that can be factored into the product of two binomials. If none of these types seem to be present, look to see if the polynomial can be factored using factoring by grouping.